Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we will talk about Chapter 3, Chemical Bonding. We will go into covalent bonding and coordinate bonding. Coordinate bond, we could also call it as dative bond or dative covalent bond. So the very first one, we will go into covalent bond. Covalent bond is the electrostatic attraction between two neighboring nuclei to the localized pair of electrons between them. Nuclei is actually the plural of nucleus. So in order to form a covalent bond between two atoms, they must share electrons. So in order to share electrons, the orbital of them must overlap. So this is the sharing pair of electrons between these two atoms, and these are the nucleus of them. So nucleus are positive charge, and the electrons are negative charge. So the positive and the negative attraction between the nucleus and the electrons is the covalent bond. So this covalent bond hold them together, and we have a molecule now. So for covalent bond to be formed, orbitals must overlap, and we have two different kinds of overlapping of orbitals. So the very first one, we will go into sigma bond. So sigma bond, it's head-to-head overlapping of orbitals. So we could actually use hydrogen molecule as example. So between two hydrogen atoms, there will be a pair of sharing electron. So each electron is contributed by each of them. So the overlapping will be happen to the valence shell. So looking into the electronic configuration of them, the valence shell of hydrogen atom here is s orbital. So the shape of s orbital is spherical. So two hydrogen atom, they will have the s orbital in overlapping. So this type of overlapping, we'll call it as head-to-head overlapping, and it gives us a sigma bond. So these are the nucleus of them. So we could have another example of sigma bond. So let's make HCl as example. So we have sharing pair of electron between hydrogen atom and the chlorine atom. So let's go into the electronic configuration of chlorine, where we have 1s2, 2s2, 2p6, 3s2, and 3p5. So p orbitals is the valence orbital of chlorine. So we make use of the valence orbital in overlapping with the s orbital of hydrogen. So this is the s orbital from the hydrogen atom, and we have the p orbital from the chlorine atom. So these are the nucleus of them, and this overlapping is also another type of head-to-head overlapping, and we have a sigma bond between them. So the last example to go, it's between chlorine atoms. So we have Cl2 molecule. So between two chlorine atoms, we can have a pair of bonding electron. So each chlorine will contribute one electron in sharing. So the overlapping will happen to two p orbitals and these are the nucleus of them. And this overlapping is another type of head-to-head overlapping. And we have a sigma bond between two chlorine molecules. So generally, if there will be a single bond between two atoms, there will be a sigma bond. Next to go will be pi bond. So pi bond is side-to-side overlapping. So this happens between two p orbitals. So the nucleus of two orbitals. So pi bond happen between two atoms where they have double bond. So example, for double bond in alkene. So the first bond here will be a sigma bond, and the second bond here will be a pi bond. So we could have also pi bond in a triple bond. So example, we have triple bond in alkyne, where the first bond will be a sigma bond, and the second bond will be a pi bond, and the third bond will be a pi bond as well. We could actually draw the electron density of pi bond in this way, where we have the nucleus of two atoms, and we could find electron above and below two nucleus. So this is what I found. We have nucleus where we don't see any electron, and we could see electrons in the region here in the orbitals. So this shows the electron density that we can find in the orbitals. Let's go into question where we have October-November 2007, paper 2, question 1b. So question 1 is to show how are two atoms in covalent bond are held together. So for covalent bond to go, is actually the electrostatic attraction between bonding electron and nuclei. So for this electrostatic, we have 1 mark. And next, attraction between bonding electron and nuclei, we get another 1 mark. So for this, we have 2 marks in total. So next, question 1 is to show the orbital overlap to produce sigma bond between H2 and HCl molecule. So what happened here? We'll have head-to-head overlapping for the two s orbital between two hydrogen atoms, and these are the nucleus, and this is the overlapping. So for HCl to go, we will have s orbital from the H atom and p orbital from the chlorine atom. So these are the nucleus, and this is the overlapping of orbitals between them. So next to go is dative bond. So dative bond is a type of covalent bond, but where the sharing pair of electron both are from one atom. So we could make use of ammonia as example. So where ammonia dissolve in water, so there will be ammonium ion and OH minus form. So what happened here? So in the reaction, so water will donates H plus to ammonia. So H plus will form bond with NH3 in order to form ammonium ion, which is NH4 positive. So looking into this, we could actually see there's 0 electron in H plus. So without any electron, H plus actually able to form a bond with NH3 in order to form ammonium ion. So what happened here is actually because there's a lone pair in ammonia. So let's see the dot and cross diagram of ammonia. So nitrogen is from group 5. So it will share 3 of its valence electron to 3 hydrogen atoms. And there's 2 more to go, which is unpaired. So this is actually a lone pair of electron in ammonia from this nitrogen atom. So nitrogen atom will make use of its lone pair to form a dative bond with H plus to form NH4 positive. So let's go into the dot and cross diagram of ammonium. So the rest will remain unchanged, where we have 3 valence electron of the nitrogen sharing with 3 hydrogen atoms, and the lone pair of the nitrogen will be sharing with the H plus ion. So from here, we could actually see the difference. So the normal covalent bond, there will be dot and cross. This shows that the dot is from the hydrogen atoms and the cross is from the nitrogen atom. So each of them contributed 1 in the sharing. But for this bond to go, so this is 2 cross. So this shows that 2 of these electrons actually is from the nitrogen atom. So this kind of sharing between 2 atoms, we will say it is a dative bond. So if the question asks us to draw the structure of ammonium ion, so we will use an arrow to indicate a dative bond. So where the sharing pair of electrons both are from nitrogen atom, so the arrow is pointing from nitrogen to hydrogen. So where the rest of the covalent bond, we just use a solid line to indicate. So these are the way where we show the dative bond. So we could actually call dative bond as coordinate bond or dative covalent bond. So we can go into another example of dative bond. So this is also a famous use example in A-levels. So where we have Al2Cl6. So Al2Cl6 actually is from 2 AlCl3. So if we have 1 AlCl3, so this is a dot and cross diagram of AlCl3. So let's complete the valence electron of all chlorine atoms. So looking into this dot and cross diagram of AlCl3, after sharing, we could actually see this aluminium has only 6 electrons, where it has not achieved the full electron arrangement. So what happened here? We have a lot of lone pair in all the chlorine atoms here. So therefore, when the AlCl3 molecules approach to each other, so easily they will form this dimer. So what happened here? It's 1 AlCl3 approach to another AlCl3, so easily the aluminium will accept the lone pair from the chlorine, and it accept the lone pair from another chlorine. So they will form two dative bonds. And this is how we get a bigger molecule, which is AlCl6. So we'll call this process as dimerization. And this dimer form, it's because of the formation of dative bond. That's all for dative bond. Let's go into question. So this is a question from May-June 2010, paper 21, question 1C. So the question wants us to show which one is the coordinate bond, and which is the covalent bond, and which one is the lone pair. So they want us to draw the circle for the type of bonding electron. So for this coordinate bond to go, so we will have this pair of electron where between carbon and oxygen atom we have two same symbols, which is both cross for the sharing. So this shows that the two cross electron is actually both from the oxygen. So we can actually see, you see the lone pair of the oxygen is a cross. So therefore these two cross is actually from the oxygen atom, and this is a coordinate bond formed between them. So the next one to go for this covalent bond. So covalent bond is any pair of this dot and cross. So carbon will contribute its electron, which is in dot, and oxygen will be the cross. So they will share electrons to form a covalent bond. So last one to go is a lone pair. So lone pair is either this two dot, two cross for the oxygen, or this two dot for the carbon. So they are not sharing. So we name this kind of bonding, this type of electron, as a lone pair. That's all for today. See you in the next video.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.